Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to the course Advanced Aquaculture Technology for the fourth lecture of module 1, which is the propagation and water budget. So, in these modules we have already learned about the basic aquaculture, some basic aquacultural things, and now we will go ahead with the propagation of fishes, water budget, water accounting, and the water footprint of aquaculture systems and managements. The first thing that we need to know about the propagation is that the breeding or the propagation, it's only an act of producing the young ones from the parent brood fishes. Okay. So, in aquaculture the fish breeding it's very important, because in order to ensure that the availability of fingerlings are there for the stocking of ponds, pens, tanks, cages, or any aquaculture facilities that you are developing in your system or aquaculture farm that you are targeting. It also ensures the species continuity and the survival, and specifically like whatever the target culture species that you are farming in your aquaculture farm. So, in order to have it in ample amount and to go ahead with the year long production and also the continuous production of the same, you need to have this propagation, you need to develop the propagation methods, or you need to go ahead with the natural, artificial. I'll discuss about it in details in the later slides. In general, the methods of propagation, it depends on different factors. Okay. So, there are different methods of propagation, but the selection of method, it entirely depends on the fish species that you are culturing, or the target culture species. It can be fish, it can be any other aquaculture species. Local environmental conditions, the facilities that are available in that in the local vicinity, and if the methods of this propagation based on these different criteria, it can be divided into three categories. The first one is the natural propagation, second one is the semi-natural propagation, and the third one is the artificial propagation. What is natural propagation actually? In natural propagation, you know, like we try to manipulate the natural conditions, and in the natural conditions we try to go ahead with the propagation or the breeding of the culture species or the culture whatever the target species that we are targeting in our farm. So, in general, say I am giving you some examples. In case of African catfish or the clarias, what we do, we try to increase the inflow of new water or the fresh water availability in the pond or in your tank, and sudden rise in this pond water level, it helps the African catfish to go for the breeding in a particular breeding season. In case of common carp, what we do, we try to incorporate more amount of grassy vegetations in the pond bottom or the pond the slope, so that it will act as a egg collecting nest for the common carps. We can go ahead with the artificial nest. We can inculcate or incorporate the artificial nest in case of American and European catfishes like the Ictalurus or the Silurus. So, in this kind of fishes, in this kind of species, this presence of this artificial nest actually very much helpful, so that they can go and the brooder fish, they can go for the propagation procedures there in the nest itself. The second type is the semi-natural one. The semi-natural one is the one where we are not completely depending upon the natural procedures, rather we try to incorporate some additional artificial methods. So, not entirely the artificial propagation ones, but it is like semi one. So, in this particular cases what we do, we try to first inject the female fish with the pituitary gland extract. So, which definitely triggers the spawning activity in them, and then what happens, these spawners or these breeders, then after this gland injection, after the injection of this pituitary gland extract, we take it out of the school and we put it in the small grassy pond, or say like an enclosure where the spawning takes place. We call it spawning tank as well. So, we try to prepare the land or the breeding area beforehand. It can be based on your construction, based on the space availability, based on the type of species, the breeding species, the type of the brooder fish that you are culturing, that you will be culturing there. So, based on that you have to design it accordingly, and all this discussion about the design and consideration, like engineering consideration, will be discussing even maybe in the later lectures. So, at this stage you just need to know that enclosure has to be sufficient enough for the breeders or the spawners to survive in a very optimum environmental condition for them to go for the proper spawning and all. So, this fertilized eggs, which after the spawning is taking place, so those are collected and they are reared under the improved conditions, either naturally or artificially. So, this kind of propagation techniques we call it semi-natural techniques. So, it's very much famous even nowadays all over the world, but in order to go for the more intensive aquaculture system sometimes, and also based on some the demand of the species, we have to go for the third and the last propagation method that we are going to discuss is the artificial propagation systems. In case of artificial propagation, it can be divided, or it can be divided in like 6 stages, 6 different stages. First, you have to go for the selection of the brooder fish. So, you have to go to the school and you have to go to the school of fishes and you just try to find out the fish, the female fish with its optimum conditions. Okay, there are different criteria depending upon the species that we need to think upon, like before while choosing the brooder fish, so that the best quality is kind of transferred to the offspring, to their offspring. So, that is why we try to have the best quality brooder fish and we select them. There are selection criteria for that, and the maturation of the brooders is the first stage. Then these female spawners are injected usually in 2 phases. Then the eggs and the sperms are hand stripped from this during this particular methods, and these eggs are then artificially fertilized and incubated in the incubation incubators, and also the this proper so to have a proper how to say, like optimum condition for them to grow, and so that they will hatch in the close supervision method. So, these eggs are like placed in a incubator, as I already told, and so that this kind of incubators are actually not so costly, but you can have it in your farm, and you can even develop it like from the local using the local technology also. So, these incubators are used to maintain the proper temperature. That is the first and foremost thing, that temperature has to be maintained, and also there are other incubation criteria as well which you have to maintain. So, in order to have these eggs properly hatched in the these incubators in a proper condition. Initial rearing of this hatched larva is carried out in a controlled condition in a rearing tank, but then soon after the fry starts they starts to feed, they are transported to the proper rearing ponds. Okay. So, there are like initial rearing ponds, and then there is like the final stage of rearing ponds. The initial rearing ponds are the like pre-straining rearing ponds, those where we go for this initial rearing of this hatched larva, and then we go ahead with the further procedure in the final the larger size rearing ponds. So, what are the advantages of this artificial propagation? So, definitely the fish seed are available for all year round. So, because in the other cases you have to worry about the proper particular breeding seasons. So if it is there in like say natural propagation or the semi-natural propagation, then you have to worry about like its breeding season, and this particular season only you can go ahead with the supplying the particular criteria, so that they will go and they will breed themselves. But in case of artificial propagation, you don't have to worry about that. It can be done all year round, and it will give you guaranteed how to say the yield all year round. Fish seed which is obtained outside the natural environment of fish, it's sometimes well, it's unless until if you can provide it with the optimum environmental condition, it can be a very high quality seeds, and you're actually targeting the brooder fish which are the best brooder fish possible. So in that case, what will happen, the offsprings will be having the higher body mass ratios, and there are different indexes which we try to target when we go for the brooder fish, selection of a brooder fish, which help to have the offspring with the high quality, and like according to our desire, according to the market demand and all. It increases the survival rate of the fry, rather than in the natural conditions they can be infested with the different diseases, that they can be feed for other predators. But in case of artificial propagation, we are trying to have it in closed supervision method. So because of the closed supervision, so we this fries can have a very high survival rate compared to the natural ecosystem, natural systems and all. It improves the quality by crossing two different species, which we call the hybridizations. So suppose we want to go for some hybridization of two different species, but it is not possible for it is very much difficult in the natural conditions, especially the natural and the semi-natural propagation methods. But in this particular method, we can go ahead with the hybridization method if you can provide proper condition, proper environmental condition, and it is doable, and it also improves the quality of the hybridization process as well. Everything comes with a advantages and disadvantages. There are other side of it. So artificial propagation has also some cons part of it. So specifically, what will happen, the donor fish, the brooder fish, that it has to be sacrificed. In most of the cases, the artificial propagation method that we follow, it has to be sacrificed, and hence the loss of fish occurs. But though it's not in a huge number, so it is doable. It is actually not that big of a advantage. The whole process is actually laborious and also highly technical. You have to have a proper technical team ready with you, and you have to have a proper expert who has all the ideas and expertise possible to go for this artificial propagation methods. Otherwise, it will not give you the proper results that you are actually expecting from your system. It's actually expensive in nature, because you have to have a proper housing, you have to have a proper the incubators, you have to install the jars, you have to install construct the tanks and etc. in a closed circulatory systems. And this, because of this circulatory system, the water that you will be using there, that has to be also recirculating in nature. So or at least the fresh water exchange has to be happen very frequently. So all these things makes it a little bit expensive compared to the natural or the semi-natural one, but it can be neutralized by, or even it can be definitely suppressed if you go for proper scientific methods, and it will even give you additional fruits as well. Because if you go for the proper propagation methods, you will get a proper good amount of offsprings, and this good amount of offsprings will give you good amount of economic benefits as well, if you can if you target proper scientific, if you go for proper scientific approaches. The next topic that I'll be discussing about the water uses in fisheries and aquaculture. So in general, the water use by the fishery sectors can be grouped into two categories: in-stream, or say like on-site water use, and the second one is off-stream, or like off-site water use. Okay. So the water consumption, okay, so water consumptions, it's actually the proportion to the water which is accumulated into the products and the lost by the evaporation, right? So because what does that mean? It does mean, like, see, the water in general fishery sectors, what are the sources of water? You use the natural streams, you use the seawater streams by the say like tide fed farms and all. You can use the groundwater by using the pump and all, pump fed farms and all. So you can use different means of natural resources. or even the artificial resources as well. Okay, so those are the intake of your water use. I would say like the water which are intaking, which you're intaking through your systems, or which are actually the water which are actually the source fed water that you are actually utilizing in your system. What are the consumption methods that what are the water consumption that actually involved with that with our pond, with our farm? Definitely the first thing is the evaporation, right? Because the pond or the tank that you are using, it has a high surface area. So because of its high surface area, what happens, because of the sunlight and because of the normal wind movement also, the water get diffused back to the water it evaporates to the atmosphere. So the water, it's keep on evaporating to the atmosphere. Because of that, we call it the evaporation loss. Okay, so this evaporation loss is the one of the major losses in any kind of ponds and all. What are the other type of losses? It's like the freshwater exchange that you need to do. Why you need to do the freshwater exchange? I have already discussed briefly when we discuss about the intensive aquaculture, that because of the intensive, when we go for semi-intensive or intensive aquaculture, we need to treat the wastewater. Either we have to treat it, or either we have to just simply throw it to the surface water bodies. Okay, because it contains a huge amount of unwanted pollutants, which doesn't let the fish or the aquatic species that you are targeting to live properly in your system. So because of that, what we do, we try to go for the freshwater exchange, so to have a proper amount of less amount of pollutant in your pond or tank, or also the higher amount of dissolved oxygen in your system. So in order to do that, you get rid of a lot of water from your systems, so which also comes as a loss of water. You know, these are the water consumptions that we normally these are the different parameters of the water consumptions that we normally talk about. Other than that, there are losses like the seepage losses. So you know what is seepage losses, right? Like, suppose you have a pond, so you have from the pond bottom, so there are a lot of water which get leached out of the system. So it will go to either go to the nearest surface water bodies, or it will go to the groundwater, go and recharge the groundwater. In one way it is good, it's recharging the groundwater, it's somehow getting collected to the river bodies and all, but actually economic point of view, we are actually losing huge amount of water, and water comes with a price, right? Because in order to exchange that water, you need to go for the freshwater exchange. You have to go to the municipality. If you are from rural sector, you have to go, and it comes with a cost because of the conduit system, the pipelines, the pump to let the water come to your systems, or maybe if you want to build a canal, that also comes with a certain amount of cost involvement and all. So all these things are involved, which are actually the main sources of water use and water consumption in your farm or in your aquatic pond, in your aquaculture pond. Okay. So in general, the in-stream water use is like water which is not removed from its source and is immediately returned with a little and or like no alteration. It's called the in-stream water use, like fishing, cage or pen cultures and vertical raceways and all. In general, these are the in-stream water use. In-stream water use means, like, in this kind of cases, we are using the water which is not something that you are applying to your systems, not something that you are having. Let's say, suppose what we do in case of cage culture or pen culture. In case of cage culture, we do it it's a type of offshore, mainly it's a type of offshore aquaculture system. What does that mean? You go to the seaside, from the bank, say like couple of meters away, couple of kilometers away, you go and develop a cage like structure. So in that cage like structure, you go for your target, culture your target species and all, and the target species is formed inside the cage aquaculture systems. But there you are not utilizing your not putting any effort to introduce the water into the systems, or you are not putting any effort to somehow neutralize the water losses from the system. So this is called in-stream water use, right? So because the water is not removed from its source, it's immediately returned with a little and very almost no alterations. Okay. So then the amount of water that is needed is the amount of water that is able to sustain the aquatic ecosystems and preserve the fish habitat. So in this kind of aquaculture systems, we call it in-stream or on-site water use. Okay. The next thing is the off-stream or the off-site water use. In case of off-stream water use, what we do, the water which is getting removed from its source is consequent reduction in the amount of available water left on site. So, in order to fulfill this reduction in the amount of available water, what we do, we add some water, we by means of fresh water exchange, we add some water by means of treatment of that wastewater itself, or there are other ways. Okay. So, this is called the upstream water use or the offsite water use systems. What can be the examples? Definitely you know it, like pond, recirculating aquaculture systems, horizontal raceways, etc., etc. So, which requires the initial water withdrawal to fill the pond and continuing water withdrawal for maintenance of oxygenation, temperature, and then dissolved solid waste removal. As I already discussed, oxygenation is one of the major factor for this kind of upstream water use, because you have to maintain a certain amount of dissolved oxygen for your culture species to survive, and also you have to maintain the temperature also. If suppose in the summer time the temperature keeps on increasing, what you need to do, you have to supply it with the cold fresh water. Otherwise what will happen, that temperature that I told you, like there are the aquaculture species are they cannot survive even a very minimal amount of temperature differences. Okay, unless until it is there are specific species which can do that, but most of them they are not. Okay, so in that, so that's why we have to be very much cautious about the temperature temperature, the pollutants and the oxygen, dissolved oxygen content of our farm, of our pond. Okay, so this upstream water use is usually it measures in terms of the water volumes that is abstracted and consumes and returned to the environment. So based on that, we go for measure the upstream water uses or the offsite water uses of our farm or of our aquaculture tank or aquaculture pond, whatever it is. Okay. So it's one of the major thing that we need to know in this particular matter is like water accounting. What is water accounting? Suppose you are like being a country like huge country like India, we have to think about the water accounting. The water accounting phenomenon it's very typical for in our case. Okay, for a country like say Singapore, it's very easy. I'm giving you one a very nice example. In case of Singapore, even few years back also they were completely depending on the Malaysia. They were completely depending on the Malaysia for the freshwater supply and all. I think it's Pekong River or something. So anyway, so but later on they started, there were some issues, and also then Singapore started they don't have any surface water resource. They have null surface water resource. So what they do, they started having treating the wastewater by themselves. Okay, and they use that treated wastewater for the consumptions also, even for human consumption also. Whatever the water that is getting generated from their grey water or black water or say like industrial wastewater, they try to treat it. They have a very high standard, the high like amount of the proper regulations and rules and regulations by their regulatory bodies, their pollution control boards, and also they properly maintain the treatment criteria and all. Then they revert it back to they again use it back to the to its source, or to its like for the human consumptions, and even for the other purposes like irrigation or the household, all the other necessary uses and all. So for human consumption, definitely they go for the maximum amount of treatment, the best quality treatment they want to go ahead with, like primary, secondary, tertiary treatment, all the treatment procedures possible. I'll discuss about these things in later slides, like what are the different treatment procedures like primary treatment, secondary treatment, tertiary treatment, which are involved with the wastewater treatment technology. So what they do this kind of thing. So for them, the water accounting is a very important tool to monitor and evaluate the source of water resources and how they are utilizing them and how it can be minimized further, like the losses in water, the consumptions in water, so how they can minimize this further. So you have to know this water accounting. It gives us a measure, it provides us a measure of availability of water resources within a country. It can be used to improve the resource management, as I told you, by means of developing structure or infrastructure for proper management of the water that is already available in your country, or the water that is supplied or imported from other countries, and how you can properly utilize it so that the minimum amount of loss can be happen and maximum amount of economic benefits or the economic loss you can adhere in a particular financial year or so. The aquaculture can have both in-stream and off-stream water use according to the aquaculture methods that we are utilizing in our farm. So, in general, when we go for this water stocking, water accounting, so what are the methods? Okay, this is very easy, this you guys already know, I think. So, the first thing is like the total addition of water. Total addition of water, it contains the precipitation, the water inflow because of from the nearby regions, and the return. What do I mean by the nearby regions? It can be from the surface water which is available there, or the groundwater inflow, groundwater in charge. It can be the return water or the return wastewater from the treatment of the wastewater that is being generated, or maybe the fresh during the procedure. During the procedure itself, you find there are some freshwater availability in that procedure, in that treatment plant itself. So, even before the completion of the treatment, you can also return it back to your systems to incorporate some amount of, say, like for nutrition requirement or for normal usage, the water quality is good enough. So, you just return it back to your system, to return back to your farm. Total reduction, first of all, the evapotranspiration. What do I mean by the evapotranspiration? You know what is evaporation, right? And you also know what is transpiration. Transpiration is the loss of water that is being happening because of the plant leaves. Okay, because through the plant leaves, the amount of water that is getting transpirated, we call it transpiration process. So, evapotranspiration is like a mutual process because of the presence of the different aquatic trees and the trees which are there in your farm. So, the losses occurred because of the losses incurred because of the presence of those aquatic trees or the normal or the land trees, and the evaporation losses because of your farm pond and all. So, all this together we call it the losses occurred because of the evapotranspiration. Okay. Outflow to nearby regions because of the difference in gravity, because of the difference in the slope gradient and all. So, what happens, sometimes some amount of water is getting lost, or sometimes they can be somehow leached out of the system. So, that is the outflow to the nearby regions. The outflow to the sea, because of the, as I told you already, it's because of the change in the gradient or the change in slope, and because of the other parameters, the water gets somehow we lost some amount of water to the sea or to the ground water, to the ground itself. So, and abstraction. So, these are the different processes. Abstraction is also involved with this kind of leaching phenomenon. So, all this together is the reduction that occurs during the which accounts to all this water losses and all this when we go for the water accounting and all. So, altogether stock at the end of the accounting period is what? It's the stock at the beginning of accounting period plus the total addition minus total reduction and plus minus variation in the water stocks. So, altogether if we can go ahead with this kind of calculations, we can find out the total stock at the end of the accounting period, and that value can be easily calculated. So, what are the direct or indirect water consumptions? The direct water consumptions for the fish cultures, and also the evaporation, which actually cost for the water lost. For indirect water consumptions in terms of water accumulated, inputs used in the aquaculture, and the water lost, indirect water consumptions during the water loss is the production process of the inputs. Okay. So, like the fish feed, we don't talk about it. We don't talk about the total amount of water requirement in the aquaculture. We only talk about the water which is, you can see it, naked eye, the visible water losses. What about the fish feed? What about the materials that you are utilizing? What about the water that is required to establish or to prepare or to procure that particular material? When you go for the life cycle analysis of a particular, of your farm, of your final product, it also involves all these water losses, passive water losses also. So recently we started talking about this, we started discussing about this, and it's a very major factor, and we need to think about it, this passive water losses and all. It's a major water loss. It's something like, you know, it's like we call it some amount of some type of technologies which are very much energy efficient or energy sufficient and all, but at the end of the day, if you calculate their life cycle, if you calculate properly, what is the total amount of energy it actually requires, like not the direct energy, not the direct energy consumptions. So if suppose some type of renewable energy has direct energy consumption, which like when you use those energy, the direct energy consumption is very less, but actually the actual loss of energy which occurs due to the production of that particular product, we sometimes avoid that. It's not a good practice. You have to go ahead with that calculations as well. You have to go ahead with incorporate those losses, those energy consumption process as well, to make that production, to make that raw material which makes that further process easier or less energy consumable, or less more energy efficient, or say like less water use and all. So whatever all this process actually involves, so you have to abide by these things. You know, whenever you calculate the total water incorporation in your system, you have to incorporate the production process, water incorporated already in your production process of the inputs, say like feeds and all. Okay, that also should be incorporated when you go for this water stocking and all. The water consumption in case of capture fisheries, definitely there is no significant water consumption. That's the good thing about it. But in case of aquaculture, depending upon the aquaculture methods, the location of the facilities or the farms that you have, the use and the formulation of the aquaculture feeds, as I already mentioned. So this is also, that is very important, and the corresponding area of cultivated crop field. So all these things are very much important when we go ahead with the consumption of the water, we calculating those things in your systems. So these are the values that we need to remember. When we go for the water footprint analysis, water footprint, it includes generally the 4 components. Okay, the first of all, water that evaporates, water that incorporated into the product, water that is not returned to the same area where it was withdrawn, and the water that is needed to dilute the pollutant concentration to water quality standards, to maintain the water quality standards given by the local authority. Say in case of Indian perspective, it's Central Pollution Control Board, or then this Namami Ganga, they have so they have this Namami Ganga mission. So they have also started having their own rules and regulations that is mandatory for all the grossly polluting industries to follow when they will discharge their wastewater to the Ganga basins and all. So these are the different regulatory bodies that you have to, these rules and regulations by these regulatory bodies that we have to abide by. And because of that, we need to provide some additional add some additional amount of water to dilute the pollutant concentration before putting into the surface water body or before releasing into the surface water body. In general, water consumptions only account the water that evaporates and the water that incorporated into the products. We don't talk about the water which is coming, which is not returned back to its source, or water that we actually add additionally to dilute the pollutant concentration in the water quality. So that is not incorporated in the water consumptions calculations. But water footprint incorporate every other details of this water footprint and all, water incorporated in the system or not. Considering the decrease in the water quality and the it actually this water footprint is good. Why we should go ahead with the water footprint analysis and all? Because it considers the decrease in the water quality, that is the consumption, and also the water quality water quantity first of all, that is the consumption, and also the water quality, the pollution. So both of these is actually involved in the analysis of the water footprint. It also can give you the access to the both water use within the country, like internal water footprint, and also the water use because of the incorporation of the other countries, mostly the neighboring countries, it's very often we actually export it, import it from other countries, like other than the neighboring countries. There's very few examples are there in the Middle East country, they do it also. So for them it's the external water footprint. Okay. It distinguishes between the three types of freshwater consumptions: the blue water, that is the surface and the groundwater; the green water, that is the rainwater or the precipitation; and the grey water, which is like the polluted water. Okay. So water footprint gives us an overall view of all the water, where all the water is involved and how it is directly or indirectly involved, and what are the consumptions pattern, what are the water uses criteria, what are the water recirculation that is happening inside the system and all. Okay. So I have taken these references to prepare this particular lecture material. So thank you so much. So I think you have had a nice idea about the different water consumption criteria, what is water footprint, and what is the water cycle that is involved in the aquaculture systems and all. Okay. Thank you so much.